All right, so this is the newest assignment, QuizR. We're supposed to convert the code you gave us to a Markdown file, which I've already done, as you can see here. Here's a quick look at the code. We'll actually go by it after we generate the file and explain everything that's kind of going on. So slide this over a little bit here. So we're going to knit the file, which will generate the Markdown file. I chose HTML. Doesn't really seem to make much of a difference. It's kind of the format you want. HTML is probably a little smaller as well, when you think about it. So it's generating that code right now. Working its magic. Here we go. So I was experimenting. I've never done a Markdown file before from scratch, so I was experimenting with some of the different arguments. So some of these may not make any sense. I actually included this one as false in the first part. Because it was loading the GeoQuery and all the different libraries and packages, and it just kind of made the Markdown file look a little uglier because it was spitting out all the console commands of like, it loaded this, okay. So I actually just set that argument to do it. So this will be the first one where we're starting. This is where this is the expression matrix, and you can see here it's getting this D set, which is 6,136 different items which it loaded, and then we put it out with the what are those the third chunk there of code, starting at like line 32 where it's getting all the data sets. Yeah, so you can see there we print it, and that prints out all that information, which is a whole lot of info. So it's all on these three sets here where it's loading everything up. Right, so over here. So the next is this comment. You'll see the comments are kind of the titles. This is a simple approach to create an expression matrix with ORFs as real names. This approach takes only one probe for each ORF, which is often true for cDNA arrays. So you get the row names and the head, and this actually kind of arranges it a little more nicely and cleanly. So you get it kind of more in a traditional. And then next, I'll scoot this up here. So this is another approach to calculate the average signals for all the probes in the same RF. And this is just everything all in one giant row, right? So you're printing out the entire row here, which is a lot. That down for the normalization expression. Data between experiments. So each column is actually a separate experiment here, and you can see the way that it's done here. We're actually using the columns and names. So you're actually getting like the title and then the information underneath it, which is done. So it's not printing out the row names, just kind of the column names. Alright, let's move this up and look at the signals. I often have log to transform microwave signals. This is a histogram of EX3. This is in the code chunk that starts on 85 there. So you got a histogram of EX3, EX4. So that's the first column and the third column. Just kind of like see the plots, histogram. Scroll here to calculate the coefficient of variation. And what was? Oh, I was trying to scroll and I'm at the bottom of the code, so it won't let me scroll. Okay, sorry. All right, you can see here, there's a ton of great information in this. So we got standard deviation, we're calculating the mean, first quarter median mean for standard deviation for my mean and my CV. This is the kind of total numbers, right? There are objects, so you can see code we got here to sort. So this is the histogram of the test my CV, the histogram of my standard deviation, and then the histogram of my mean, and that is the bottom of the code. So that is the bottom of the Markdown file. You can go in and make them kind of prettier and easier to read. So I did a lot of experimenting just to kind of get this. I'll go ahead and save it, and I guess that is it. All right, thanks.